Hi, this is your math facilitator, Naomi Andrick, and I wanted to go over this distance, rate, time kind of problem that was on one of the assignments for week 2 for my students. It's one that a lot of people have difficulty with, and I don't think that the explanation that my math lab provides is sufficient. So that's why I wanted to go over it. Here's the problem. It has a little picture. It says, at first an athlete jogs at 5 miles per hour and then they jog at 6 miles per hour, traveling 10 miles total in 1.8 hours total. How long does the athlete jog at each speed? And then there's this really important hint. Let t represent the amount of time the athlete jogs at 5 miles per hour. Then 1.8 minus t represents the amount of time the athlete jogs at 6 miles per hour. So basically we have two distances. We have this first distance we can write an expression for with one speed, 5, and one time, t. And then we have this second distance here that we can also write in an expression for with one speed, 6, and one time, 1.8 minus t. So the key equation that you have to know going into this problem is that distance is equal to rate times time. That's assumed to be knowledge coming into this, but it's something that you'll find is true. You know, if you think about, well, what would the distance be if I traveled 60 miles per hour for an hour? You'd multiply 60 miles per hour times 1 hour, the distance would be 60. So, or 60 miles per hour for 2 hours. Well, you do 60 each hour, so you'd have 60 times 2 to get your distance. So that's fairly common usage, but that's what we're going to use here. But we have a more complicated situation here because really we have our distance equal to two distances added together. I'm going to call them D1 and D2. Normally I do little subscripts, but I'm not going to bother with it right now. So D1 can be this first distance in my diagram, the distance traveled at 5 miles per hour, and D2 will be the second distance in my diagram, the distance traveled at 6 miles per hour. And finding those two, let me just move that over, maybe not quite so far. If I want to find D1, I'm going to do rate times time, but here my rate is 5 and my time is t, so I'm just going to have 5t. 5t again is my distance 1. Those are the same thing. And then for distance 2, see if I can get that. Okay, distance 2 will be, again, it's rate times time, but I've got a different rate and a different time. So for the second distance right here in my diagram, the rate is 6 miles per hour, and the time is 1.8 minus t. And I don't bother with changing that to minutes or anything complicated like that. I just let it be in hours for the whole thing. The answer should be in hours. You know, everything's in hours. Okay, so now I've got these two expressions, and I will just take this equation and change my D1 into 5t, and my D2 into 6 times 1.8 minus t. Let's see, ignore. Well, sorry about those squigglies. They're not going to go away. So now I've got this, and then I also have more information. I know the total distance is 10, so I'm going to change that to a 10. And now I have a linear equation with just one variable that I can solve. And I would go through just kind of your standard steps. I'm going to cut the picture off since I'm pretty much done with it now. I'm just going to copy that down. So first I would distribute the 6, which means I need to have 6. Just going to use x for my time symbol there. I'm going to have 6 times 1.8, and then also 6 times t over here. 6 times 1.8, if you pop that into a calculator, just multiply it out, that is going to be, gosh, what is it? 6 plus 4.8, so I'd have 10.8 as my number there, and this is just 6t. If I take this equation and then I combine like terms, I have 5t minus 6t. Those are my 2t terms, and I would end up with a minus t there. I'm going to change this to a minus t and just get rid of this part because I subtracted. And then if I solve this, I might add t to both sides to get 10 plus t equals negative t plus t. That part goes away. Equals 10.8. And then I might subtract 10 from both sides so that I have t all by itself on the left. And then I'd end up with t equals 10.8 minus 10, which is 0.8. Now, t, I said at the very beginning, said let t represent the amount of time the athlete jogs at 5 miles per hour. So when I go down to enter in my answer, it looks something like this. So he's going to jog for 1.8 hours at a speed of 5 miles per hour. So that's my answer for that part. I'll make it green. And then I also need to say how many hours he jogged at 6 miles per hour. So to find that, I go back 1.8 minus t. So the second time is going to be 1.8 minus 0.8, which of course gives me 1. So scrolling back down, this will be 1 hour in this case for the second time. So here in my diagram, he would go 0.8 for 5 miles per hour, or 5 miles per hour for 0.8 hours, and that would give me 4 miles. And then he would go 6 miles per hour for 1 hour, and that would give me 6 miles, and 4 miles plus 6 miles is in fact 10 miles like I wanted for this particular problem. So that's how I would personally work this problem. I'm a little tempted to call t the time for 6 miles per hour and 1.8 minus t the time for 5 miles per hour. You could switch that up. It doesn't really matter, and you would get exactly the same answer. You would just get this one first and then use it to find this one instead of the other way around. So that naming of variables doesn't have to be exactly like they suggested, but it is nice that there's a hint there to get you started. Okay, that's all. I hope this helps. Bye.